Hello guys, welcome to the Metasploit Mega Primer Part 4. Now in the previous video we looked at the Meterpreter core commands as well as some of the commands offered by the Stdapi extension. In Part 4 we will go ahead and look at some of the other interesting commands offered by Stdapi and also by the Priv extension. So before we move forward, there is one interesting concept which you need to be aware about, which is Windows desktops. Let me quickly illustrate why this is important. Let's actually go back to our Metasploit terminal and quickly exploit the XP machine. So this is exactly the same setup which we've used multiple times, right, if you remember. Okay, so now when we actually look at the available commands, what we had pointed out in previous videos, that you have the enum desktops, get desktop, set desktop, and UICTL or UI control. Let's look at what each one of this does and understand desktops in the process. So let me quickly run a command called enum desktops. So if you notice, the first thing you look at is session, second is station, and third is name. So just keep in mind that right now we are looking at all session zeros, and station consists of both WinSTA0 and SAWinSTA, and name, default, disconnect, WinLogon, and SA desktop. Well, if we go back to our slide, the session, very simple way to think about sessions is ways in which you can interact with the Windows machine. Well, session 0 is typically the console. So currently, as far as the Windows desktop is concerned, we've actually broken into a process which has access to the console, right? All other sessions, session 1, session 2, etc., actually represent remote desktop sessions or remote terminal server sessions, right? So this is what session number 0 means here, which is basically what we are looking at in these desktops belongs to the console. Now the second thing we look at here is WinSTA0. Well, this is the only interactive window station available within a session. Well, just by looking at what is under WinSTA0, you would be able to figure out what it does. The first is default, which is the actual desktop. This is where all your programs run, your Internet Explorer and all of that. Then you have disconnect, which probably is being used when your screensaver is actually coming on, and probably it is getting locked using a password. Finally is WinLogon. Well, WinLogon is basically when you go ahead, log off, and you actually have the logon screen, right? Let me just quickly show you how that looks like. Well, this is basically the WinLogon desktop, right? Now, apart from this, rest of all the available stations and desktops under them are non-interactive window stations, right? Which means basically they cannot interact with the keyboard and the mouse and all the other graphical elements which generally is required for an interactive window station. So with this in mind, there's something very interesting. WinSTA, as we mentioned, WinSTA0 is the only interactive window session in every session possible. Why do we say every session? Well, one is the actual local session where you log on to the console and do your work. Alternately, you could have used a remote desktop session to log on to the machine, or some sort of a terminal server session, right? Now, here is something very interesting. Basically, the window station is nothing but an object containing a group of desktop objects, right? And each one of these desktops under WinSTA0 has its own keyboard buffer. Now, what I mean by that is, the keystrokes which are actually being entered once you log in, the buffer it goes into is different from the one where you would enter when you're at the logon screen. So what we enter here goes into a different keyboard buffer versus what we enter once we actually log in. So once we log in, anything we enter right now after logging in, right, is going to a different keyboard buffer. Now this has some implications as well as going ahead and actually monitoring logon passwords. So very quickly, let me summarize. There are multiple sessions possible. Session 0 is the one which represents the actual console. Session 1 and above would be remote desktop sessions as well as terminal server sessions. Under every session, there are multiple window stations available. The only window station which allows interactive access is WinSTA0. All the other stations, window stations, are non-interactive in nature. Under WinSTA0, typically you have 3 different desktops. First, default, which is basically where after you log in, you probably run your programs, run Notepad, Microsoft Word, etc. Disconnect, and finally WinLogon. WinLogon is the familiar one where you actually enter your logon password to connect into the system. So with this in mind, let's now go back. And these are all the accessible desktops. So let's quickly look at what is the desktop we are associated with. Right? So if you notice, our desktop is basically the one of the service desktop which is non-interactive in nature. Right? So one of the first things we might want to do is actually look at a process which we are very sure would be running in the interactive window station or WinSTA0. So I'm very sure explorer.exe, which is running as the user which is currently logged on, definitely would be using a interactive window station which is WinSTA0. Right? And that too in that the default desktop. So let me go ahead migrate to 436, which is explorer.exe. Once the migration is done, let me hit get desktop once again. And now if you notice, we are basically in session 0. WinSTA0 is the window station and default is the desktop. Right? So now if we go ahead and actually do a key scan underscore start, which is actually nothing but monitoring the keystrokes, what we will only be able to do is monitor keystrokes in the default desktop. What I mean by that is, once you log in, well, at this point, anything you enter will be part of the keystroke monitoring process. So let's go ahead and do a quick dump. And if you notice, I entered Notepad, entered return. Right? Let me go ahead, stop the keystroke monitor for now. Right? Now, there is something very interesting which you will note right now. Now, let me probably go ahead and migrate this process to SVC host, right? So that we are running in system mode. Now we are back here. Now let's go back here and log off. Right, so we have the familiar logon screen. And if you look at the available processes, well, right now there is no explorer.exe simply because there is no logged in user for which the process would be invoked, right? So let us try doing something. Let us try, because all processes are anyway running as simple services, right? So what we will do is, let's try and do a key scan once again. Now let me go back to the virtual machine and type in something. Let's come back here and actually do a dump. So if you notice, it was not able to capture any of the keystrokes, right? And the reason for that is that the desktop we are associated with is basically not the WinLogon desktop. So only when we are associated with the WinLogon desktop would be able to actually actually monitor the keystrokes. Now the best way to do that is to migrate to the winlogon.exe process, which seems to have a PID of 52 in this case. Was it 512? Okay, it was 512. Right? So once we migrate, if we look once again, hit get desktop, you would actually notice that currently we are in session 0, which is actually the console session. WinSTA0, which is the interactive Windows station. Within that, we are on the WinLogon desktop. And this is what we are seeing here right now, right? So let me actually once again enter the password. Now let's go back. Oops, I forgot to start the key scanner. Let me go back here, start the key scanning, go back to the console, type a password, go back here, and let's hit a dump right now. So now if you notice, we were able to monitor the keystrokes on the WinLogon desktop by migrating to a process which had access to this desktop. Now this is something which is very, very important, where always remember that especially when you want to go ahead and do interesting things on the UI, you need to migrate to a process or have some way to go ahead and access the active desktop on which you want to go ahead and run your programs, right? So let me show you one interesting program here, and that is called UICTL or UI control. Now what UI control does is it basically allows you to control the keyboard and mouse. Now one of the interesting things you can do is just disable the keyboard. What this does is it disables the keyboard on the remote machine. Now you cannot really look at it, but I am trying as hard as possible to type, but I'm unable to type anything because the keyboard has been disabled, right? I can go back here, enable the keyboard, and go back here, and now I can type whatever I require. So now notice once I log in, I'm associated with the default desktop of the Windows station, of the only interactive Windows station, WinSTA0. Now here is another little interesting thing. So let's say I go back and I disable the keyboard again, right? Now let me go back to my Windows machine and let's see if I'm able to do anything. If you notice right now, my keyboard seems to be working. So once again, the same principle applies. We are currently in a process which is associated with the WinLogon desktop. And if you notice in the slide, I told you that each one of these desktops has its own keyboard buffer. Hence, the only keyboard we have disabled right now is the WinLogon keyboard. The default keyboard, the keyboard associated with the default desktop is still active. So what do? Well, we go ahead and migrate to a process which currently is running on the default desktop. Right? And then we verify. Great. We are on the default desktop, which is what you get to once again if you log in into a Windows machine. So now let us go and disable the keyboard. Now let me go back. And if you notice right now, actually I'm typing, I'm trying as hard to type, but I am unable to type anything, right? In order to activate my typing, I need to enable keyboard again. Perfect. Right, now I'm able to type whatever I want. Great. Right, so is this part about the desktops clear? So this is very important, because whenever you want to monitor keystrokes or do something interesting, it is important to know and understand which desktop in the interactive window station, which is WinSTA0, is your current process associated with, right? So these are a couple of commands which we have seen. We can also try and set the desktop using the set desktop command. Right? So by default, it will actually go ahead and set the desktop as default in the Windows station WinSTA0. You can try to use this command and change your desktop based on whatever privileges you have once you've broken in. Right? Okay, so the next extension which we will look at is Priv, which stands for privilege. Right? So let's go to the console. Now, Priv has 3 listed commands. Get system is something we will look at in the next video after we understand about impersonation and Windows tokens, right? For rest of the video, we will just concentrate on these 2 commands, which is hashDump and timestomp. Now on a Windows system, all your usernames and hashed passwords are stored in a file called the SAM file. Now hashDump goes ahead and actually fetches them from the SAM file and displays it to you. Now what one could actually do is save these passwords and run a cracker like offcrack, which is very easily downloadable, and maybe after a couple of hours, if commonly used passwords have been used on the remote victim, or maybe a password which can be broken by a very simple brute force has been used, then one could even get the password used by the admin or by the user, right? So this is what the hashDump utility does. The other utility is called timestomp. Now in order to use timestomp, let's actually go to our vulnerable server. We are in C drive, and let's say as a hacker, we will go ahead and run a couple of commands. So we are currently here. Let's change our directory to C drive. If you look at our present working directory, this is C drive, right? Now what we could actually do is create a file here. Now let's say very simply, we can even use the shell command, go to C drive, and just simply use the echo utility to create a file, right? Let's exit from the shell, back to the Meterpreter prompt. If we look at our Windows machine, you would notice the hacked file has been created. And if we look at the properties, well, creation time is just about right now. Right? Now this is worrisome because during a forensics investigation, or if let's say the user does even a very simple search on the latest files created, this file would be visible, and this is something which should be which should actually make the whole hack easily detectable. So timestamp actually manipulates the file's mace attributes. So what do I mean by mace? Well, very simply, mace stands for the modification time, the file access time, file creation time, and when the file entry was modified on the file system. Now, what one needs to do is modify all of these values to ensure that it feels as if this file was not created because of a hack, but was maybe on the system already. So let's go back here, give a -h to look at the various options. Well, one of the very simple options is to go ahead and, let's say we want to change the creation time to right. Now if we actually go back here, and do a quick refresh and view the properties, you would notice that the creation time has been changed to September 8th, 1980, right? And the actual minutes, hours, and seconds. Now similarly, we could go ahead and change any one of the other values, such as the let's say the last written time, using the -m attribute, right? We go back here to our virtual machine, refresh, have a look, and you notice now the last modified time has also changed. Now one of the interesting things which you could actually do with timestamp is basically take the mace attributes for an existing file on the system and go ahead and modify the file which you have created, its mace attributes to that. So as an example, let's say on the remote system, okay, some reason this is not loading, but no problem, we can go back here. On the remote system, there is this file called confidential.txt which has certain attributes. So what we can do is we can actually use timestamp, right, to take an existing file's attributes using the -f command. This is confidential.txt, and give it to our file. Right, so if we now go back, let's do a quick refresh. Now confidential was actually created somewhere around 31st of August 2010. If we looked at the properties of hacked, you would notice exact same creation and modification time is present there. Well, access time, the issue is whenever you access the file or any of its properties, it automatically changes. But that is not something you need to worry about, right? So one thing which you could do is before leaving, just change the timestamp and leave it as is. The moment you access it, the access time changes. But coming back to our presentation, okay, so there's another command called get system, which we will look at later in the next video set after understanding about tokens and impersonation. Well, that's all in part 4, where if you look at it, we've covered the entire Meterpreter STD API extension set as well as the Priv extension. My voice might sound a bit low because I have a bad cold with a sore throat, so please excuse me for that. Hopefully you've understood all that I have said. Quick request, please request that you leave comments behind on whether you liked this video, disliked it, hated it, would want something more in it, because it's your comments which are the only things which keep me going, right? Well, that's all for this video. Thank you.